Hello, let's take a look at another Maclaurin series. This is going to be our second example, but in this one it will be slightly different for part B, where we have to find the Lagrange error term. Before we get to part B, let's start off with part A, and we see here that they have given us a function f of x. So for all Maclaurin functions, what we have to do is we have to go and find the first, second, third, and fourth derivative. So let's write it out. F of x is equal to e to the x times sine of x. Then my first derivative, I will use the product rule, differentiation with the product rule, e to the x times sine of x plus e to the x times cosine of x. Then my second derivative, again, I have to use the product rule, and then this will simplify to 2 times e to the x times cosine of x. Then for our third derivative, we're going to find negative 2 times e to the power of x times, and we can make a little bracket here, sine of x minus cosine of x. This is just in simplified form. You can go and find the derivatives by hand for each one of those. Then for a Maclaurin, remember a Maclaurin is actually a Taylor series at x equal to 0. So what we can do is we can evaluate f at 0, the first derivative at 0, same for my second derivative at 0, and third derivative at 0. The original function f at 0, remember sine 0 is 0, so therefore this one is going to be 0. First derivative at 0 is going to give us 1. Second derivative is going to give us 2. Third derivative will also give us 2. Now, for a Maclaurin series, we have the following. We know that f of x is equal to, so it's going to be f0 plus the first derivative at 0 times x plus the second derivative at 0 times x squared over 2 factorial plus my third derivative at 0 times x cubed over 3 factorial. Now we can go and substitute. We found f0 to be 0 plus 1 times x plus 2 times x squared over 2 factorial plus 2 times x cubed over 3 factorial. 3 factorial is 6. 2 over 6 will simplify to 1 over 3. So we can rewrite this as x plus, in this case here, 2 over 2 factorial is just 1, so x squared plus x cubed over 3. Now, what I should have done was I should have indicated that this series continues. So I should have indicated here plus, etc., plus, etc., plus, etc., because this series continues. They only wanted from us to write this series up until the term x cubed. So that we have done. So this is the answer for part A. Now let's go back and take a look at part B. The Maclaurin series is to be used to find an approximate value for f 0.5. Use Lagrange form of the error term to find an upper bound for the absolute value of this term. Now this is not in the formula booklet, so this is definitely something worth remembering. So here what we have is, this is the error term. The error term Rn of x, and this is the formula. Now we have found, in our working out for the approximate value, we have found up until the third derivative of x. So the third derivative of x, that gave us up until x cubed. And what you will notice here is, for this error term, so this Rn of x, this n will mean that for our error term, so in this case R3 of x, for the error term up until 3, we want to find the derivative of n plus 1. So if n is 3, then we have to find the fourth derivative of x, and we are going to substitute in a c, multiplied with x to the power of n plus 1. Remember, n is 3, so x to the power of 4 all over n plus 1 factorial, so 4 factorial. Okay, this is just to tell you a little bit about n, to see how n influences here. So what we will have to go and do is we will have to go and find the fourth derivative. Also, let's talk about this c value that we are going to substitute in here. So c is an element between 0 and x. We all know that in Maclaurin, x is equal to 0. So for this c value, for this approximation, we are saying for this approximation, it deviates between 0 and a value. So between x is equal to 0 and another value for x. Now, let's go and take a look at the question that they gave us. They have given us the Maclaurin series. We have to find for the approximate value for f 0.5. That means c is an element of 0. It is always 0. 0 is always my lower bound, and 0.5. So this x value here is going to be 0.5. We can see here c is an element between 0 and x, whatever x value it is. And this will be my upper bound for c. So let's put all of this in practice. So let's go down here. We had our third derivative of f. So now what we have to go and do is we have to go and find the fourth derivative of x, the fourth derivative of this function. And the fourth derivative is going to give us negative 4 e to the x times sine x. So this is my fourth derivative. So if I want to find the error term for the approximation that we have, for n is equal to 3, so this is r3x. Now let's go and use that formula. So the formula says f4c multiplied with x to the power of 4 over 4 factorial. Now we have the fourth derivative and we're going to substitute c in for x. So this is going to become negative 4 e to the power of c times sine c multiplied with x to the fourth all over 4 factorial. So this is the error term that we had to find. But now the question, so let's stop here and let's go back to the question. Now the question did ask us, use the Lagrange form of the error term to find an upper bound for the absolute value of the error in this approximation. So they want to find an upper bound, absolute value of this error approximation. Now, because they ask for an upper bound, I am going to use the upper bound of c. We have spoken previously that c is an element between 0 and 0.5. So if they ask for the upper bound, I will replace c with 0.5. So negative 4 times e to the power of 0.5 sine 0.5 times x to the power of 4 over 4 factorial. But we can replace this x as well. Remember, they ask us to evaluate f 0.5. So 0.5 will go into the place value of x. So we can substitute in here 0.5 to the power of 4. Now, when we evaluate this, we will find a value negative 0.00823. But the question asked for the absolute value error term. The question asked for the absolute value. So what we're going to do is we're going to take the absolute value of this, and therefore it is 0.00823. So this is the approximate error. So let's go back to the question just to make sure we have answered it. Use the Lagrange form of the error term to find an upper bound for the absolute value of this error approximation. So what we have found is the upper bound. Now for part 2, deduce from the Lagrange error term whether the approximation will be greater than or less than the actual value. Now, we have found that this error term was negative. Remember, we took the absolute value thereof, but this was actually a negative value that we have found. So, B part 2, since this is a negative value, we can say that it is greater than. So remember that if this error term is negative, we can say it's greater than. If my error term is positive, we can say it is less than. So in this case here, we can say it is greater than the actual value of f 0.5.